The objective today is to describe what the Intel manual says about assembler and compiler addressing modes. So it says at the machine code level, the selected combination of displacement. Remember the last video went over what displacement is? Remember in part 19 it said how can we determine an offset? Well, you can do a calculation using a mixture of these values. Or right there, if you specify the offset directly, in that case, we're going to call that displacement. So displacement is when a programmer in assembly is specifying the offset themselves. Or I guess I should say the compiler can do that as well. So good thing we're reading about assembler and compiler addressing modes. Let's go down here and say that the selected combination of displacement, base register, index register, and scale factor is encoded in an instruction. So what is inside of an instruction? The offset, or actually we should say the effective address, because this term effective address is referring to an address created out of a calculation of these one or more of these things. And as a review, we could go over here and look at all the different ways that this was calculated. Sometimes it's a simple addition, sometimes it's a multiplication and then an addition. There's just a variety of ways to calculate. So what was a good question for us to type here? Let's change the first question to another one. Let's say, what can one find in an instruction? And I could put parentheses and say, at the machine code level. They go on to say, all assemblers permit a programmer to use any of the allowable combinations of these addressing components to address operands. So operands need to be addressed. Remember, an operand is a value, and an operator is an action that is taken on the operands. Okay, you can see here I'm trying to turn a little paragraph into a lot of talking. Let's continue by rereading this real quick. So all assemblers permit a programmer to use any of the allowable combinations of these addressing components to address operands. High-level language compilers will select an appropriate combination of these components based on the language construct a programmer defines. Now for our first field trip, let's talk about if compilers are going from source code to assembly to then machine code, because after reading this sentence, I realized there is a difference between an assembler and a compiler. These are actually two different programs that their job is the same, though, in the sense that they take the assembly language or they take a high-level language and they turn that into machine code. So my question was, do compilers go from source code to assembly and then to machine code? Unless we're talking about the compiler doing that job as well. So in that sense, can a compiler also be an assembler? Well, to answer this curiosity question I just came up with, I went over here to Stack Overflow. All right, here we are. And here's the question, does a compiler always produce an assembly code? And I'll let you pause here if you wanted to read the question itself, because they're referring to GCC specifically, but I want to take you to the last two answers, actually. I liked them the most. Some witty username says that it's a matter of compiler implementation. Assembly code is an intermediate step between higher level language, the one being compiled that is, and the resulting binary output. Remember guys, binary output is machine code. In general, it's easier to first convert to assembly and after that to binary code instead of directly creating the binary code. Aquarius Girl says easier, but the interpreter doesn't do that. It directly converts to machine code. So for compilers, isn't it a wastage of time? I'm thinking the same thing she is. And I always wondered about interpreters. I wondered how they can actually exist, because I assumed they would still need to compile. So the term interpreter can be confusing. But in that sense, man, what a great analogy. An interpreter is to a compiler as some compilers are to an assembler. There we go. I wanted to change that I for consistency. So what that's saying is they are both. An interpreter has to compile, and a compiler has to assemble. Well, actually, as we're about to read, it doesn't always have to assemble, but it often does. So somebody username has a good response here, kind of clarifying what I just said, that interpreters are compiling, but they're doing it every single time, or at least every time it's ran, aka executed. But let's read this answer, probably my favorite, and it's the done by the old timer here, or a old timer. GCC does create the assembly code as a temporary file, calls the assembler, and maybe the linker, depending on what you do or don't add on the command line. Now down here they say running GC without any options absolutely creates an assembly file. Now, there is no need for this. It is simply how they happen to have designed GCC. I assume for multiple reasons you will already want or need an assembler and linker before you start a compiler. We haven't even talked about a linker at all yet. That'll have to be a separate video, though. And because I like any mention of Unix, let me read this last sentence here. The Unix way is to not reinvent tools or libraries, just add a little on top. So that would imply going to assembly, then letting the assembler and linker do the rest. You don't have to reinvent so much of the assembler's job that way. And so this next part is how I would answer number 2 here. The question being, do compilers go from source code to assembly to machine code? Here's your answer. It is easier for a developer to debug ASCII assembly, the mnemonics used in assembly, than the actual bits. And then Old Timer says, folks have been doing it this way for generations of compilers. Just-in-time compilers are the primary exception to this habit. By definition, they have to be able to go to machine code, so they do or can. Only recently, though, did LLVM provide a way for the command line tools, LLC, to go straight to an object without stopping at assembly, or at least it appears that way to the user. So what I'm saying in terms of an answer, let me just change this to like answers to above, okay? Okay, so based on Old Timer's response, I would say compilers should go to assembly in case of the need to debug. And maybe comma GCC does. And big smiley face. GCC has a pretty good reputation. LLVM there is from the Apple guys. Alright, and then our last question of the day, what is a programming language construct? If I go over here to Wikipedia, good old Wikipedia, a programming language construct is simply like the keywords that you use to make the language work. So here's an example in PHP, as well as many other languages, I'm thinking Python. When you say print, that's a construct. The computer will know what to do with that command, print. And it seems this construct will work whether there are parentheses or not. If we go down to in a Java class, when you say public class, my class, and then write code, like here's the constructs. So real simple concept that I may have been thinking too much about. They said high-level language compilers will select an appropriate combination of these components, the components of address and instructions, and they're doing this based on the language construct a programmer has defined. So I think Intel maybe could have written that more simply by just saying high-level compilers will use the appropriate combination of these components based on the language a programmer used. And just because it's easy, let me actually do one more. It says I/O port addressing. The processor supports an I/O address space that contains up to 65,000 8-bit I/O ports. Ports that are 16-bit and 32-bit may also be defined in the I/O address space. An I/O port can be addressed with either an immediate operand or a value in the DX register, and then you can see that chapter for more. So that's very curious. I don't think anybody who's watching this video series would spend any time working on this, but maybe. And to really wrap your mind around this whole I/O port addressing concept, I'd encourage you to buy an Arduino or a Raspberry Pi and mess around with those. And if you can't afford it, go to YouTube and watch somebody mess around with an Arduino, and then you'll really understand port addressing. So final question of the video, what is I/O port addressing useful for? And the answer would be so you can take in input or send out output, probably using the DX register here. You can take in input and send out output based on that address. So that's it for today. Next time we will begin Chapter 4, talking about fundamental data types.